Hey everybody, after this last Wednesday night's webinar, some questions came up about the xform command and how do you use it. And so I thought I'd put together a little video just kind of demonstrating some of the more common arguments used when you're using the xform command. So let me go ahead and just create a cube and just start and explain here. So one of the commands you can actually use is to move it in space. So you actually have a relative command and a world space command. So you can transform this guy to 555, and I moved the channel box over here so you guys could actually see it. So you can see it's moved to 555. And if you do this with the R command, if you keep running that with the WS, which stands for world space equals true command, it'll stay in the same spot basically all the time. And if you use the R command, which is relative, not rotate, it's relative, and you run that command, you'll see that it just keeps adding to it. So watch the numbers over here on the left. You can actually see that it just keeps going up by the value of 5 every time I hit the enter key. So it ends up way out here in space, right? Okay, so that's relative. So if you want to just keep adding values up, you totally can. And then run the world space command again to get it back here at 555. So another way you can actually get values of things is to use the Q, which stands for query. So you can query the translate. Notice here you're supplying it. When you're trying to move something, you supply it with a tuple of 3 values here. When you want to actually get the value, you use the Boolean here, true or false. Like, what is it you want to get? I want to get the world space position, true. I want to get the translate, true. And I want to query that, true. So if you actually run this command right here, you'll see that it gives you 555 as floats. So let's just move this guy off in space, just some other place here. Like this. So here's the values of where I just moved it. Let's see what that position is. So we'll just run the query command. And you can see these values up here, these really detailed float values with a lot of precision are the same as the float values here inside the channel box. So if you need to get the value of something to see where it is in space, you can actually use that. Okay, so now let's talk about some rotation, some cool objects about rotation here. So EU stands for Euler or Euler. I prefer Euler pronunciation. Both I've heard common around work. So what you want to do is you want to do RO, which is rotation values, 44, 45. And as long as you do Euler angles, it's going to change these values right here, your Euler angles. And sometimes they're compatible values, so it's 45, 45, 45. That's fine. The cube has no problem with that. But sometimes, if you add a value, sometimes some of the values don't match up in space here, right? So I'll show you that here in a minute. And once again, you can add the R command here to be relative, and Euler commands here, so you can actually add those values here. And you'll notice I said 45, 90, and 120, and I did not get those values whatsoever, right? Because I did relative. And if I keep adding that relative, you'll just see it just keeps adding those rotation values, and the numbers just keep climbing up and up. So if I wanted to go back to the default value here, I just take off the relative command, and it takes me back to 45, 45, 45. Okay? So world space, it'll also rotate you in world space to 45, 45. So imagine we just group this guy. I'm just going to group him at the origin here. And I'm just going to rotate this guy wherever he is. I'm just going to, oops. So I'm just rotating this this group node wherever I need it to go, right? So I just rotated this guy any number of values, so I'll just put a 10 on there, whatever it is. Okay? And now if I actually ran if I actually do the Euler value of this on the inside and click this, you'll see inside it's 45, 45, 45. But if I add the world space command, you'll see the rotation changes to some crazy weird numbers on the inside here. But if I unparent this, Shift P, you'll see now, because now I'm back in world space, by world space comparisons I've put it to 45, 45, 45. Now I want to show you some situations where this can be kind of weird. So imagine I take this cube right here, and in world space position and Euler rotations, I put them in here. And you'll notice I put in 45, 90, and 120, but here it says minus 75, 90, and 0. Why would that be? Well, you'll notice here, if you look closely, that my my x and my z rotation, whoops, This thing's got to get fixed soon. My X and my Z rotations are in gimbal lock. They can't achieve the position that I'm actually trying to achieve. So the two rotation axes are actually on top of each other. And so it causes sort of a little problem, and that's because the middle value is 90. And so if I actually went and took out the world space argument, I'd get the right values that I wanted, but you notice it looks like it stays exactly the same. Let's try that again. I'll go with the world space argument on, and you'll notice the values are minus 75, 90, and 0. Those aren't the values I entered, but if I remove the world space command, you'll notice the cube did not move in space, but the rotation values are there. And that's because this is actually in gimbal lock right now. So if I just change these values to, say, add a 1, it's like 91 degrees and not 90. Now if I click it, I get the values I want in world space, because they're not going to be in gimbal lock. So just by 1 degree difference, I actually get the values of rotation I want, and then these two values are not changing. So you have to be careful using the Euler rotate command. If you're going to try and position something, most times programmers will actually create a matrices and then use the matrix to position the cube. Yeah, so that's a different topic altogether. But if you wanted to get the rotation values on one of these cubes, you would actually do the same thing. Add the Boolean true, query true, world space true. Let's get the world space rotation values of this cube, and it will return back 45, 91, and 120. As close as it can possibly get anyway, binary-wise. So, yeah. So one of the things you can check here, so if I set this guy back to 45 degrees, 45, 45, 45, he has a matrices in space. So if I actually just record that, I'm just going to record it with PyMail here for a second, just for the purpose of explaining here. So if I recorded this, whatever I have selected, I get the matrix off that guy. Oops, I have to import PyMail. Let's just import that. So I'm going to take whatever I have selected on this guy right here, and I'm just going to save it. So if I look at this matrix up here, you'll see it's a matrix type object, and I have some values that I've stored, right? This is at 45, 45, 45, by the way. So now if I set that with this value right here. So now if I set it with the world space command at 45, 45, 45, and now it's got a slightly different rotation. It doesn't look like it changed, but it did slightly change. And if I get that matrix, I've now recorded position 1 and position 2. And visually, they look exactly the same. Let's actually just compare them with the two equal signs to see if they're true. And in fact, they are exactly the same matrix. Now, remember, we had this one actually looks good. So if we actually do the world space position with 91 instead of a 90 here, let's go ahead and do that. Okay, so we've rotated him here, 45, 91, and 120, full values. And with this guy selected, we'll just record that matrix real quick into position 1. And then we'll use it without the world space command, and we'll record it. Okay, so now the position is still in gimbal. You can kind of see it's only like 1 degree off gimbal. Let's record that matrix into position 2, and let's compare those two. They are not the same values, but if you look at them right next on top of each other, these values are identical values. So that means only by the most minuscule values do these matrices not match up. See, these all look exactly the same to me, all the way to, I don't know, what is this, 9 degrees of accuracy, of precision here. They look exactly the same, but they are not being matched up as equal here. So, but you don't see the position change at all. So just to let you know, we're only 1 degree off of a gimbal lock here, so you might get some really strange values. But if we actually went to like 95 and 95, we will probably get a little closer to a non-gimbal situation. So let's record that one. And let's record this one. And let's just test here. These are probably not going to be the same, but I'm just trying to show you. Yeah, so they're not exactly the same, but you can start to see them coming off of gimbal lock here. Anytime you don't have a matrix where you have an orthonormal basis, it's kind of something that's beyond this course right now, but you will get two different matrices. They will not exactly be the same. But if you're running into this situation where your rotations are not following, like this 45, 90, 120, this actually will generate a gimbal situation here. So be careful when you do those rotations, okay? You might want to probably rotate something in space and then record those rotations, and then you'll know that those are decent rotations instead of just adding in random numbers in here. Okay, cool. All right, this is 10 minutes. I just wanted to show you some of the xform commands like rotate, translate, and of course there's scale. And you can find those in the Maya commands for the Python command reference. Just open it up and hit X. It should be one of two commands in there, something like that. Yeah, so just type xform, and you'll see a bunch of examples. Ignore the matrices stuff on the bottom, and the examples at the bottom are horrible right here, but you can actually get an idea just by playing with some of these things. Okay, great. Let me know if you have any questions.